Hello students, welcome to Physics Pathshala. Today we'll cover error analysis, lecture 2. In that we'll be find out the different methods how to find out mean absolute error, relative error and percentage error. Already we have discussed every measurement is absolute error and random error, that is unknown error or variable error, that cannot be find out its we cannot find out its exact value. For that we have adopted different methods. That is here three different expressions we'll have to express error. Mean absolute error, let us find out the steps to find mean absolute error. As per principle, if we'll take number of measurements and take its average or mean, it will be very nearer. It will be very nearer to the true value. It will be nearer to true value or exact value of the item. The more numbers of measurement will take, will be able, you will be more nearer to the true value. Now, what we'll do, this average or mean value of all measured values. Suppose in first step we found in first measurement the measured value is measured value. First measured value is A1. Second measurement we have taken measured value is A2. Third measured value is A3. Now what you have done, then taken average of these measured values or mean of these measured values. That means average A1, A2, A2 summation of these measured values divided by number of measurements. This is the average. Average means sum of the measured values divided by number of measurement. Here we have taken three measurements, hence divided by 3. This is A mean, and this value will be termed as assumed true value. This will be termed as true value. That is assumed true value, assumed. Now, any difference between this true value, assumed true value, and measured value gives the error. Now here error is AM minus A1, for this measurement AM minus A2, for this measurement AM minus A3. That means this is absolute value error, absolute value for these measurements. This we can say this is delta A1, this is delta A2, this is delta A. Now, this it is termed as absolute error. Absolute error for each measurement. For first measurement, absolute error is delta A1. For second measurement, absolute error is delta A2. Third measurement, absolute error is delta A3. Now we'll take mod of all this measurement, because in some cases it will be more than AM and some cases it less than. When it will be more than, we'll find negative. Sometimes it will be positive. Now we'll take mod or positive value of these absolute errors. That is a1 mod, a2 mod, delta a3 mod. These are the errors associated with each measurement. Now, average of these errors, that is delta AM, that is delta A1 mod, delta A2 mod, delta A3 mod divided by 3, because number of measurement is 3. This is the mean of absolute errors. Now we got absolute errors. These are the absolute errors, the mod taken. Then we have taken out the mean. This is the mean of absolute errors. Whereas a true value will assume measured value of item will be measured value of item, assume true value plus minus this will be the error. Sometimes it will give plus, or sometimes it will be minus, or measured value of the item will be a m plus this, or we can assume m minus this, or the value will be between m minus delta m plus delta m. This is the error part and this is the assumed true part, and considering both, that will be the measured value of any quantity. In this way we could find what is the error part and what is the measured value of the item. Now next is, what is the relative error? Relative error is this mean absolute error divided by assumed true value. This is assumed true value. This is delta AM by A. And percentage error is nothing but it's the relative error multiplied by 100 gives the percentage error, or delta AM by AM into 100 is the percentage error. In next class we will study propagation of errors or arithmetic operation of errors. Suppose this arithmetic operation means it may be addition, subtraction, or it may be multiplication or division. If any physical quantity we found out is addition of two quantities, addition or subtraction, or any physical quantity is multiplication of two quantities, we have error associated with the first quantity, we have error associated with second quantity. What is the error associated with the final physical quantity? That will be addition of or subtraction of these errors. Now, if quantities are added, we have physical quantity PQ1, that is addition of two quantities, or another quantities we have that is subtraction of two quantities, and we have error due to this is delta a m. Error due to this b quantity b is delta b m. Here we say error associated quantity A is delta A m. Error associated with quantity B is delta B m. Error is the uncertainty or loss. When we say this is giving certain loss, this also is giving certain loss. When both are combined, definitely both will contribute loss. That means error of PQ will be error due to A, error due to delta A, delta B, and both will be added. In this case also, this PQ, error due to PQ1, and now error due to PQ2, that is subtraction of these two quantities, error will be again added, because this quantity has given some uncertainty, this also has given certain uncertainty, both have contributed, hence error will not decrease, this will contribute, this will contribute, in both case both will contribute, hence error will be added. Whether quantities added or subtracted, errors will be added. Here pq1 was a plus b, error were added. Here pq2 was a minus b, sorry, a minus b, and their errors got added. This error is mean absolute error, mean absolute error of A, and this is mean absolute error of B. That means if two quantities are added or subtracted, their mean absolute error will be always added. If any quantity is formed, any physical quantity, let it is X, it is formed by multiplication of other quantities, and their power is A, B, and C. Then error due of this physical quantity X, error of physical quantity X, we have to find out. Here, if quantities are multiplied or divided, their individual relative errors will be added. In previous case, when quantities were added, subtracted, their mean absolute errors were added. But here, if quantities are multiplied or divided, then their relative error will be added. That means relative error of x will be relative error of p, relative error of q, relative error of r. And this error will be relative, their relative errors will be added. Here P is A times. Then it means P will contribute A times, Q will contribute B times, and R will contribute C times. Suppose, for example, x1 is P square Q. Then relative error of x1 is equal to relative, this quantity you can say P into Q. That means relative error of P plus relative error of P plus relative error of Q. That means P contributed twice, or twice relative error of P and relative error of Q. That means this power became how many times this P contributing error. In similar way, if x2 is equal to P3 Q square and R4, then relative error of x2 will be 3 times relative error of P plus 2 times relative error of Q plus 4 times relative error of R. Now it shows this, if powers are A, B and C, then their relative error will be A times P, A times relative error of P, B times relative error of Q, C times relative error. This is the, if two quantities are added or subtracted, it will be, then this will be error of this final quantity, and it is expressed in terms of relative error. And do we know relative error can be expressed in percentage error simply by multiplying 100. It shows percentage error of x is equal to percentage A times percentage error of P, B times percentage error of Q, and C times percentage error of R. In next class, we will do number of examples on this mean, absolute error, relative error or fractional error, percentage error, so that error analysis will be completed. And after that, we will study what is significant figure. Significant figure is the important term associated with measured value of any measurement. This is linked to again error associated, or error existing in measurement. Error existing in measurement. Hence, significant figure is the only solution to our measured value. This will give very certain rules we have to find out significant figure to get the measured value nearer to the true value.